4 identical resistors are connected to a battery as shown. Each resistor has a value of 120 ohms. When R4 is removed, what is the effect of removing this R4 from this circuit? So the first thing you have to do is find the effective resistance, that is the total resistance in this circuit. And what are you going to do? The first thing you do is get the total resistance of R2, R3, and R4 because they are connected in parallel. And when resistors are connected in parallel, you do 1 over R total equals to 1 over R2, which is 120, plus 1 over 120, plus 1 over 120. So you have 1 over R total to be 3 over 120. Then you have to flip to get R total equals to 120 over 3, and that is 40 ohms. Now we're looking for the total resistance, so you have to also consider R1 because R1 is in series with the combined resistance here. So that's going to give us 40 plus R1, which is 40 plus 120, and which means you get 160. All right, so the total resistance here is 160 when you have your R4 connected. So the next thing we're going to do is we're going to remove R4 and find the effective resistance in the circuit. Now when you remove R4, you have R2 and R3 connected in parallel, and when you have 2 resistors connected in parallel, there's a shortcut, which is the total resistance is the product and over the sum of these resistors. That is 120 times 120 over 120 plus 120, which is 240. So 0 cancels 0, 12 in 24 is 2, 2 in 120 is 60. Now combining these two with R1, because of course they're in series with R1, so that means you're going to get 60 plus 120, which is 180. So it means that when you remove R4, the total resistance will increase from 160 to 180, which means the effective resistance has increased by 20 ohms, which is option C. Alright, so I'm going to be solving more questions under electricity before we move on to the next part of physics you get to see every time. Don't forget to subscribe, like, and comment, and then share to people who need this video. Thank you.